what that means. So, does anybody know what this symbol is? If you've been on a college campus and gone down the street that has all the fraternities on it, you've seen that symbol. Anybody know what it is? It's a sigma. It's a capital letter sigma. And what sigma means to the mathematicians, it means summation. So this is a summation notation. This tells me I'm going to add something. Okay? Now, what I am adding is very, very easy. Okay? I start with this number right here. Now, that number is often a 1. When you write your own sigmas, which we'll be doing soon, you will probably start with 1, but it doesn't have to be. If you look at the second example B, it starts with 2. It does not matter. All right? I'm starting with 1 this time, so I'm just going to put a 1 right in here. What does that equal? If I put a 1 in there, what do I get? 5. So the first number I'm adding is going to be 5. Now I'm going to put a 2 in there. That will be a 7. And then I'm going to put a 3 in there. And then I'm going to put a 4 in there, and I'm going to stop. Any idea why I'm stopping with 4? Because that's the top number, right? So in sigma notation, this is the beginning, this is the end. And you go every single whole number in between. And then we calculate each one of those terms, and now we'll just take out our calculator and we'll add them up. Or that one's easy enough, some of you can probably just add it in your head. Just add it up. And we get our sum is 32. So easy. Whenever you see a sigma in math, it is your clue to add. You are going to be adding something. Now, this particular set of numbers, did you notice it was arithmetic? Now, they don't have to be arithmetic, obviously. This one happened to be. All right, let's try the next one.
Yeah. A little bit sad, but yeah, I'm excited too.
So when I add these up now, I do exactly what I just did. I start right here, plugging this in. Kaden, I can't see you. So I'm going to plug this 2 in, and the first number I'm going to add is 1. And then I'll plug a 2 in, or 3 in, and then I'll add a 2. And a 4 would give me 3, and a 5 would give me 4, and a 6 would give me 5. And the answer to the question, this is called the expanded. This is the sigma expanded. This is like a shorthand, and this is the whole expanded form. And now we're just going to add those up. So what do we get? Let's see, 9, 12. You get 15?
Yeah.
Hey, Zeus.
Why is there only like 5 digits up there?
Why is there only what?
Why is there only 5 numbers up there? There's just 6 up there. Because in the first one you put 4 numbers, like they were adding, there's a 4, right?
Okay, wait, where do you see 6 numbers? I don't see 6
oh,
numbers.
never mind, I see. Never mind.
You got it figured out?
Yeah.
Okay. Okay. All right, let's do the last one. Try the last one on your own. It will not be arithmetic, but that's okay.
Wait, this 4, shouldn't there be a 6 on the end?
Shouldn't there be a 6 here?
Yeah.
Okay, wait. What do I get when I put 6 in? This is the last number that I put in. These are the numbers I put in. I'm not adding these numbers. These are the numbers that are going in. This is what I'm adding up. So when I put a 2 in, the first number I add is 1.
So you're like you're substituting up to 6 numbers, but you're not going to have 6 numbers to add.
I'm substituting 2 through 6.
Yeah.
Yes. All right, so do that last one. See if we can get that last example on this page done. So what are you adding? What's the first number in your list here? No, the first number in your list is not 1. The first number in your list is 2. Put 1 in for n. That gives you your term. This gives you your term right here. Put 1 in for n. So the first number you're adding is 2. And the second number you're adding is 4. And the third number is 8. And the fourth number is 16. So that's a little geometric progression. We're going to add it up. And is that 30? And that's the sum. All right? Oh, we got another one here. You can see there I made a little note and said, whoa, whoa, time out. Why? I'm a little concerned. There's going to be a lot of numbers here to add up. And it isn't going to be hard to do. I mean, I'll put in 1, and then I'll put in 2, and then I'll put in 3, and I'm sure there'll be some kind of pattern. And that's just hunky-dory. But if I'm typing them all into my calculator to add them up, I'm going to have 100 of them. Right? I really don't want to do that. I could. You could. It's doable. It's just going to take forever, and it's tedious. So we're going to back up a minute. First of all, let's look at the first few terms of this and see what kind of a sequence it is. So if I put in 1, just to get started, my first term will be -1. And then when I put in 2, I'll get 1. When I put in 3, I'll get 3, and so on. And I will be going all the way. The last one would be 197. Because how do I get the last number? I plug in this, right? So those, there's dot in there, there's a whole bunch of numbers in there. But that's what I'm adding up. Agreed? All right, so hang on to that thought, because now I want to show you something. This is a true story. It's in the encyclopedia. You can find it. I may have like the age wrong or something, the exact age, but long time ago, over there in Europe, only little boys went to school. And it was like a Friday afternoon before Christmas break or something. And the little boys, this was like, they were 3rd or 4th grade, and the little boys were like driving the teacher crazy. So the teacher said, okay guys, here's what I want you to do. I want you to add up all the counting numbers from 1 to 100. I want you to add these up for me. Now, 3rd and 4th grade kids can do that. It takes a long time. And probably when you walked into the room, if I would have said to you, I want you to add up those numbers, you would have done exactly what the teacher knew those kids would do. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and just keep going right down the line. That his purpose was to keep them busy, okay, which it would do. So the teacher's thinking, okay, this is going to get me to the end of the day. They'll be busy, occupied, won't cause any trouble, whatever. The teacher no more than got sat down at his desk, and up came one of the little boys with the correct answer. Now remember, there weren't any calculators or anything like that. This was like back in the 16 or 1700s. That was a long time ago. 1700s, I think. So he comes up with the answer. And the teacher's like, what? Wait a minute. Where did this come from? And the little boy, his name is Carl Friedrich Gauss. And if you remember, when we were doing matrices, we talked about Gauss-Jordan reduction, the RREF thing. That's him, a great mathematician. But he was just a little boy. And he said, this is what you want me to add up, teacher. This is the sum you want me to find. But I know that addition is commutative. So that same sum would be gotten by adding up in the other direction, which you would all agree, right? It won't matter which way we went. So if I take these two equations and add them together so that I have two of my sums, what happens? This would be 101. What would this be? Another 101. What would this be? Oh my gosh. There are 101s all the way down to the end. So how many of these 101s are there in this line? 100. So two sums equals 100 101s. So one sum would be 50 101s. And there's your answer. Now, you got to be impressed. I mean, this is a little kid. That's pretty impressive. But here's why I'm telling you this. His strategy is the basis of a formula that you can use to add up any arithmetic series. This is arithmetic, adding 1 each time. Yours is arithmetic, adding 2 each time. And we're going to use that same idea. So let's generalize this. Here was his sum. Where did the 50 ultimately come from? In his problem, how did we get 50? The number of terms divided by 2. This was 100 divided by 2. So for us, if we want to add up, we're going to take half of the number of terms. And then he multiplied it by 101. Well, where did the 101 come from in his problem? It was the first term plus the last term. So the first term plus the last term. There is how you are going to add up any arithmetic series. When we add them, we call them a series instead of a sequence. If you're adding up the terms of an arithmetic sequence, that will be the formula that you will use. N stands for the number of terms you're adding up. A sub 1 is the first term. A sub n is the last term. So with that in mind, let's come back to our problem. We are adding up 100 terms. Would you agree with me? If I start at 1 and count to 100, that's 100 terms. So my formula will be 100 over 2. My first term, I already figured out, but I got it by putting in 1, so that was negative 1. And my last term, I get by plugging in 100.
Later.
So that was 197, and that will be the sum. So I'll just put that in my calculator, and that will be the sum. Sigma notation is absolutely wonderful for this because sigmas always give you the first term and the last term. So the answer is 9800. So the value of this sigma, this is a value 8, that's going to be 9800. Now, what was the key to using this formula? That sequence had to be arithmetic. Okay? This will work as long as your sequence is arithmetic. Well, what if it's not arithmetic? What if it's geometric? Well, I do not have any cool stories for the geometric formula. I know you're disappointed. So I am just going to throw it up here and tell you this is the formula for a geometric series. Now, you already know what all of those letters mean. You already know that A sub 1 means first term. You already know that R is the common ratio. We're talking about a geometric series, right? And whose desk is that? Whose stuff is that?
Sam.
Who?
Sam Tuttle. You had to go to the office last class.
Okay. So 1 minus R. On the bottom, 1 minus the ratio. There he is. You right. Did I put two papers on your desk? Yeah, did I put papers on your desk? Exam review? Okay. All right, so let's try the next problem, because the next one is going to be geometric. Now, I know it's geometric because I have this huge advantage having done this for billions of years. If you're not sure what it is, do what we did. Start writing out some terms. If we put in a 1, if you put a 1 in here, that will be 0. Anything. Okay, this is not good. This is very weird. Hang on just 1 second. Hey, Sam. Sam. Okay, we're all good. It's all good. Okay, so what did you get? Did you get -2 when you put in 1? Put 1 in here. 3 to the 0th is 1 times -2 is -2. All right, now let's put in 2. Let's put in 2. So now we have -2 times 3, so that would be -6. And then I'll put in 3, and I'll have -2 times 3 squared, so -18. And that's probably enough for you to figure out what's going on. This is geometric, and the common ratio is 3. Now, because it's geometric, you will not be using that formula. You'll be using this one. How many terms am I adding up? 15. So the sum of 15 terms, according to our new formula, is the first term, which is -2, minus the first term times the ratio to the 15th over 1 minus the ratio. Okay? Now, you can do a little bit of cleanup work. I always, before I go to my calculator, figure this out. Because if I don't make it one number, when I put it into my calculator, I'm going to need parentheses. Remember, if you ever have more than one thing down there, you need parentheses. So to avoid that, I'm just going to go ahead and subtract 1 minus 3. Now, if you think there's any chance of you getting confused, I would just type it in exactly as it is. But won't these two negatives cancel each other? So if you want to cancel them and you are comfortable doing that, this is what you could type into your calculator. But if you are worried about canceling, just let the calculator deal with it and type it in exactly as I wrote it, with the parentheses. All right, so let's see if we can all get the sum. Here we go. Don't forget, before you do divided by -2, you have to hit equals up here. You got to type in the top and hit equals, and then divided by. And I think the answer is -14,348,906. Does anybody match that? Okay. Now let's look at the next one. Do you notice anything different about the next one? It doesn't have a number on the top, which effectively means what? It goes on forever. forever, right? So instead of there being an end number out here, if I started writing them out, it would just be dot, dot, dot forever. Okay? So wait a minute, how do I add something up that goes on forever? Well, let's take a look at it and see. First of all, I want to look at some of these terms so I can kind of figure out what's going on. If I put a 1 in, what do I get for my first term if I put in a 1? 2. And if I put in a 2, I would get 6 times 1/9, which is 2/3. And if I put in a 3, I would get 6 times 127, which is, let's see, 3 goes into there, 2/9. Can you figure out what's going on? What kind of sequence do I have? Geometric, and the ratio is 1/3. The problem is that formula is not going to work for me because I don't have it. I don't know how many terms I've got. Okay? So I want you to think about something that we talked about the other day. What happens when you raise 1/3 to higher and higher powers? It gets closer and closer to 0. And if you go big enough, you'll never actually be 0, but you will be so close to 0 that when the calculator rounds off, it'll be like 0. It's going to get so very small. So what I'm trying to get you to see is this term right here is going to go to 0. Because as you raise 1/3 to higher and higher powers, that's going to go away. That's going to become 0. So all you're going to have left is a sub 1 over 1 minus r. Because this is going to get so very small. You can ignore it. This is the sum for an infinite geometric series. It has to be geometric, it's infinite, and whatever r is has to have an absolute value less than 1. Because what happens when we raise numbers bigger than 1 to powers? They explode. There's no way to sum it. If you think about trying to add 2 plus 6 plus 18 plus 54, you can't do it. They just keep getting bigger. So the key to having an infinite series, being able to sum it, is whatever the ratio is, it has to have an absolute value less than 1 so that the terms are getting smaller. That will cause this to go away, and then you can add it up. So what is the sum in this problem? Well, it is the first term over 1 minus the ratio. You already told me the ratio was 1/3. I'm multiplying by 1/3. So that'll be 2 divided by 2/3, which is 2 times 3/2. So the sum of that series is 3. So in that empty space there where it says formulas, you should have 3 formulas written. You should have this one labeled arithmetic sum. You should have this one labeled geometric sum. And you should have this one labeled infinite geometric sum. All right. Any questions so far? This is better than a movie. All right, so now, Tyler always thinks we ought to have a movie. All right, so now you're going to write your own sigmas. So you're going to take the expanded form express that as a sigma. Now, the first thing you probably want to think about is coming up with an expression that you can plug in your numbers and get these terms, right? That's what you need to do. Well, believe it or not, that's so easy. What kind of a series do I have up here? Arithmetic. And I know, I'm trying to come up with an expression for the terms. And I know that an arithmetic sequence can be described with this terms. These are the terms of an arithmetic sequence. So for this problem, a sub n, so some term will be -1 or -7 plus, what's my difference? How am I getting from term to term? 6 times n minus 1. So in other words, it's 6n minus 13, is that right? That, my friends, is what goes right here. That's it. That's all there is to it. So now you know what you're going to plug your numbers into. And notice, if I put in 1, do I get -7? And if I put in 2, do I get -1? Yeah, we're all good. What's the only thing missing? There's a number up here. And I know there has to be a number up here because the sequence ends. So now I'm going to think backwards. What am I going to plug in to here that will give me 53? You see what I'm doing? So 6n minus 13 has to be 53. So what is the n going to be? 11? Everybody okay with that? Pretty easy, not bad at all. The hard part, but it's not even hard, as long as you remember. To get this expression, you're going to use your arithmetic formula if your thing is arithmetic. I don't think the next one's arithmetic. What's the next one? Oh Lord, what is the next one? What's happening in the next problem? Don't overthink it. Do you recognize those numbers? Is there anything special about those numbers? They're the cubes. I don't need a formula for that. Isn't it just n cubed? And I'm starting with 1 because the first number in my series is 1 cubed. And the second number is 2 cubed and 3 cubed and so on. That's it. Now, is there a top on it? Nope, because you don't end. You keep going. Now, this one would not be summable because the terms are not getting smaller, they are getting bigger. And if you have an infinite number of terms, the only way you can sum it is if they get littler. That was easy. All right, what about this one? So it's geometric and the ratio is -3. So since it's geometric, I need to use my geometric formula, not my arithmetic formula. So our geometric formula, remember, for terms is a sub n equals a sub 1 r to the n minus first. So our first term is 5. Our ratio is -3. And it's to the n minus first power. That is what you write here, kids. There's no simplifying. that's what you write here. And before you start getting, confused or whatever, because that's a little ugly, remember, if you start with 1, what happens if you put 1 in here? 0. Anything to the 0 is 1. So we have 5 times 1, which is 5, our very first term. That's it. There's no lid on that one either. All right. One more. Okay. We did an example of arithmetic, we did an example of geometric, and then we had that random cube thing in there. What is going on with D? Well, whatever it is, it's going to infinity. Can you see what's happening there? The first term is 1. What's the second term? So 1 times 2 maybe? And then the third term is 1 times 2 times 3. And then the fourth term is 1 times 2 times 3 times 4. Yeah, don't we call that factorial? So we're summing in factorial. 1 factorial, 2 factorial, 3 factorial. All right, part 3, we're going to actually find some sums. Now I gotta keep an eye on the time because I want to do one other thing too. Okay, all right, so let's find some sums now. So we got -3, or -7, -3, 1, 5, 9, 13. Don't forget, tomorrow is the first day you can bring in your cereal if you want. So please consider doing that during office hours. Bring it in, 2 boxes or 1 box. All right, so our job is to find the sum. This is not very many numbers. Could I take out my calculator and type them right in? Sure I could. Because we're getting used to our formulas, I'm going to go ahead and do it with a formula. But quite honestly, if I only have 6 numbers, I'm probably just going to add them up individually. But here's what the formula would look like. Arithmetic or geometric? Arithmetic with a common difference of 4. So I have an arithmetic formula that tells me this will be my sum. How many are we adding? What's our n? N is the number of terms. How many are you adding? 6. So the sum of 6 terms will be 6 over 2. The first one is -7. And the 6th one, or the last one, is 13. So 3 times 6, if you add all those up individually, you should come up with 18 as your answer. Is that okay? All right, now what makes the next one a little bit trickier? Well, first of all, there's a whole bunch of terms. Second of all, I do not know what they are. I don't know how many there are. There's a gap in there. So, would you agree it's arithmetic? With a common difference of -7? So I'm going to use the same formula. I'm going to use this formula. And I know the first number I'm adding is 117, and the last number I'm adding is 33. In my formula, first term plus last term. How in the world am I going to figure out n? I really don't. I mean, I could, I suppose, you know, just keep counting down. I really don't want to do that. Any thoughts on how we would find n? Well, it's arithmetic, right? And whenever I don't know what else to do, I'm going to dig out my other arithmetic formula. Could this be of any use to me? This formula says that the last term, 33, has to equal the first term, 117, plus the common difference, which you already told me is -7, times n minus 1. So I know everything in that formula except n, and that's what I need in this one. So I'm going to solve this. I got 13. I subtracted 117, divided by -7, and added 1. So I got 13 for n. Is that what you got? Somebody? Anybody? So then, that's like work over to the side. So now I'll take that 13 and put it into my formula. So the sum of 13 terms will be 13 over 2 times 117 plus 33. So 117 plus 33. So my sum is 975. If I did it right. This is the answer to the question, but I had to do this work in order to get what I needed for my formula. All right, let's see if we got any more of those. Oh yeah, let's do a couple. Let's do these last two, and then I'll stop and we'll do something else that we need to do. All right, so here we go. Next one says, find the sum of this. Well, what's going on here? Well, so it's geometric and the ratio is 3. So the formula I'm going to use is this one. I'm not using my infinite formula because I have a stopping point. So this is the one I'm using. And am I where I was a minute ago? I have some of the information, but I'm missing a very critical piece of information. So what did I do over here when I didn't know how many terms I had? I used the other formula. This time, the other formula I'll use will be this one because it's geometric. I know the last term is 98415. The first term is 5. You told me the ratio was 3, so now I need to solve that equation. How do I do that? Divide by 5 first. Absolutely. Absolutely. This is, yeah, you need to divide by 5 first. So 98415 divided by 5 is, oh good grief, so 19683 equals 3 to the n minus first power. What do I do with that? We have two choices. Obviously, doesn't this have to be a power of 3? So you could mess around with it, and, take 3 to a power and just keep trial and erroring until you figure out what that power is. So, I don't know, what's 3 to the 10th power? Too big. So 3 to the 9th power. There it is. This is 3 to the 9th power. I didn't do anything mathematical except trial and error, which is very mathematical. It's perfectly okay. Now, if 9 equals n minus 1, then n must be 10. Now, what if you don't want to do trial and error? How do I solve an equation like this? This is on your exam. How do I solve an equation like this? Logarithms. Exactly. So, again, you have a calculator. So feel free to log both sides. And when you pull your exponent off, then you'll take the log of that number divided by the log of this number. And add 1. Now, on your exam, you're going to have to use logarithms, but in this unit you don't. Because if that sequence is geometric, this number has to be a power, in this case of 3. So you will always be able to trial and error it. But you won't be able to trial and error on the test because it's going to be something like 3 to the x equals 17. You're not going to be able to, you're going to have to use logarithms on the exam. But here you don't have to do that. You can do what I did originally. Just play with it. 3 to what power? All right. So one way or the other, we figured out that n was 10. So now I'm ready to answer the question. I need to find the sum of 10 terms. The first one is 5. The ratio is 3. I'm going to do that denominator first. Type it in and get my answer. $147,620 is what I got. So the last two problems we've done, we haven't known n, and we have used our other formulas, our first formulas, to figure out n. Then we've been able to just plug everything in and get the sum. All right, one more. One more. What's happening in this one? Sure, I'm thinking I have a mistake there. What's happening?
Is it being multiplied by 5?
Yeah, but that shouldn't be a 0.2. That should be just a 2, shouldn't it? Yeah, so let's just make that a 2 and hope like heck everything else works out. Make that just a regular 2, not a 0.2. So it's geometric, and we're multiplying it again. And we're multiplying by 5. So my formula, 0.08 minus 0.08 times 5 to the nth, I don't know that, over 1 minus 5. So I am stuck here. Rory, we're stuck. How do we find n? We're going to go back to our old formula, original formula. And we know 1250 is the end, 0.08 is the beginning, and the ratio is 5. Now I'm going to solve that equation, which looks just like the one we just solved. How do we start? Divide, so 1250 divided by 0.08. I'm hoping this works, people. Oh, 15,625 equals 5 to the n minus first. It's okay, I know. I was going to sell it. All right, what do I do now? You want trial and error? So 5 raised, oh, I'll start with the 8th. Too big. So 5 raised to the 6th. There it is. So this is 5 to the 6th power. So what's my n? 7. So I can pop right over here and put a 7 in here. I'm going to go ahead and make that a -4. I'm going to type it in and be done. So 0.08 minus 0.08 times 5 to the 7th equals divided by -4. 1562.48. Mind-blowing. That's enough of that. I need you to do one thing for me. I need you to get out your homework, limit homework. If you've turned it in, I've turned it back. If you did electronically, you got it. But I really want to look at that limit homework because a bunch of us were missing these problems. And you still got full credit. You turned it in on time. But we really shouldn't be missing these limit problems. So find your limit homework. All right, so you're looking at it?
I pulled out my phone.
Huh?
I pulled out my
Yes.
phone.
All right, what's the answer to number 1? The answer is -3. And why is the answer -3? Because on the top we've got a 3n squared, and on the bottom we have a -1n squared. So when we line up power over power, it's going to be -3. Now what about B? 0. Because the thing you're raising to a power is less than 1. And that's all that matters. So that's going to be 0. Now, C is a little bit tricky. What is the limit of the first part of the problem, the first parentheses? 3/4. What's the limit of the second parentheses? 1/3. Everybody good with that? And they're being multiplied. So it's as simple as that. Find the limit of each piece and then do whatever you're doing, which in this case is multiplying. So that should be 1/4. That limit should be 1/4. What about D? 0. You do not have an n squared on the top. So it's 0. What about E? Divergent or no limit. Why? Because the number being raised to the power is bigger than 1. What about F? 0. Kids, if that 3/5 raised to a power, that's going to 0. Timesing it by 2 is still going to go to 0, right? Now G, a little bit tricky. The limit of a constant is that constant. So the limit of the 2 part is 2. then I'm adding the limit of the second part of the problem, which would be what? 3? So the answer to the problem is 5. H is my trick problem. H, I got tricky. I do that once in a while. H is divergent. And it's divergent because, see the negative n? What does that negative n do to the fraction? Flips it over. So it's really 2 to the nth. You see what I'm saying? And that's divergent. So that is a tricky one, for sure.
So that's no limit.
So that's no limit. H is no limit. What about I? Divergent because the power on top is bigger. Right? And then J is another two-parter. What's the limit of the first piece? 4. What's the limit of the second piece? 3. And I'm subtracting those. So the answer is 1. 4 minus 3. Grace, are you asking me a question? You got that? Okay. All right, well, good timing on that. So, hopefully that straightened out any issues there.